Now we shall have a look at how to solve the corner isolation problem using Marchand's algorithm. The patterns from class 1 are indicated here. -1, -1. Then we have -1, 1, 1, 1, and 1, -1 belonging to class 1. These patterns. Now, how many patterns are there belonging to class 1? There are 4 patterns, and patterns belonging to class 2 are here 0, 0, 0, 1, 0, -1, 0, 0, 1, and 0, -1. So these are the patterns which are there. We need to separate these patterns. Now if at all, I have just indicated these patterns. If at all you do not want to, if at all while drawing the lines, if at all these patterns are confusing, then we can just hide these particular, the coordinates x1, x2 which we have written for it. So at the beginning, what is the data set? We have T0 plus and we have T0 minus. Now T0 plus is the number of samples which are left to be classified at the beginning. Now plus indicates to class 1 and minus indicates class 2. So this notation plus T0 plus, it means for the class 1 samples. So T0 plus is nothing but -1, 1, 1, -1, 1, 1, and 1, -1. So basically this is nothing but T0 plus. And what is T0 minus? T0 minus is all the patterns belonging to class 2 in the beginning. So -1, 0, 0, -1, 0, 1, 1, 0, 0, 0. So this is T0 plus and T0 minus. Next we have N0 plus and N0 minus. N0 plus is number of samples which are lying under the set T0 plus. So T0 plus is the set which we have defined. So that means all the samples which are belonging to class 1 at the beginning, because it is N0. And N0 minus is nothing but the number of samples in class 2 at the beginning. So that is N0 minus is equal to 5, because there are 1, 2, 3, 4, 5 patterns in that particular class 2. Now we move on to the step 1. We need to select a particular line which will be separating the points. Now here there are patterns which are shown, patterns belonging to class 1 and patterns belonging to class 2. The line which you select should be such that any of the class patterns, either class 1 patterns or class 2 patterns, should be completely classified. So nothing should be remaining on one side which is yet to be classified. So where I shall select line? I shall select the line somewhere here such that this particular pattern is classified. So whatever is on this side of the line is completely classified, and which class it is? This pattern -1, 1 belongs to class 1. So one pattern of class 1 is completely classified, and on this side this is unclassified. So basically what we have is that the line should be selected in such a way that on one side of the line all the patterns should be classified, and on the other side of the line the patterns can be unclassified. Okay. In the last step we will have both the sides classified. But here we get one side, because in step 1 we have one side which is classified, other side which is not classified. So now we write the equation. So for this particular line, there are 2 intercepts. The line is intercepting with the x1 axis -1.5, and the line is intercepting with the x2 axis at 1.5. So we shall be selecting the equation for the line, and the line is named as O1. So the equation for this line is nothing but x1 upon -1.5 plus x2 upon 1.5 is equal to 1. So which direction we are looking in? We are looking in this particular direction, which is the upward direction, and 0, 0 should not lie on in this particular region. So I can simplify this equation as minus x1 plus x2 minus 1.5 is equal to 0. Now when I substitute 0, 0 in this, I get the answer as minus 1.5. That means that 0, 0 is not lying in that particular region which is upwards. So it is correct. So I can say that the equation which we have selected is correct. That is O1 is equal to minus x1 plus x2 minus 1.5 is equal to 0. So at the end of this, what we get is that we have to now check what is classified and what is yet to be classified. So what is T0 plus T1 plus here? After step 1 we will be getting T1 plus. Now from T0 plus, this particular pattern is classified. So we are left with minus 1 comma minus 1, 1 comma 1 and 1 comma minus 1. Now any pattern is being classified from T0 minus. None of these patterns are classified. So I write T1 minus is same as T0 minus. So now, how many patterns were there initially in class 1? 4, and in class 2? 5. Now one of these patterns is already classified here. So I write as N1 plus is equal to 3 and N1 minus is equal to 5. Now we move on to the step 2, wherein we have to select another line which will classify patterns from a particular class. So I have selected a line O2 which is here, and what this particular line is doing is that it will classify the pattern. This pattern it will classify. So again this pattern which it classifies belongs to class 1. Now what is the equation of this line? Equation, this particular point is nothing but minus 1.5 and this particular point is 1.5. So I can write the equation of O2. So O2 is nothing but x1 upon 1.5 plus x2 upon minus 1.5 is equal to 1. If at all I simplify this, I will get x1 minus x2 minus 1.5 is equal to 0. Now again we check whether this particular point 0, 0 lies. If at all we substitute 0, 0 here, again we get minus 1.5. That means it is not lying. And yes, if at all you see these arrows, 0, 0 is not lying. That means this equation which we have got is correct equation. So we write this equation as x1 minus x2 minus 1.5 is equal to 0. So this is the equation which we get. I have written what is T1 plus and T1 minus. Now we have to find out what is T2 plus and what is T2 minus. So what is T2 plus? T2 plus, what is getting classified here in this, because of line O2, is this particular point is getting classified, and this rest of the region is the unclassified region. This is already classified previously. So this whatever I have circled here, that is the unclassified region. So we have 1 comma minus 1. This particular point is gone from here. So T2 plus will be nothing but only from class 1. Only 2 patterns are remaining to be classified. So I write N1 plus is equal to 2. And T2 minus is same as T1 minus, because nothing has got classified from this particular class 2. So N2 minus, this is N2 plus, N2 minus is equal to 5. So altogether how many patterns are left to be classified here? If at all you see 1, 2, 3, 4, 5, 6, 7. Now you can do this particular problem the way you want, but I will be in the first 2 steps we have selected the lines such that they will be classifying the patterns from class 1, that is T1 or T1 plus, or T2 plus we have reduced. But now for a change I can continue with classifying, and I can say maybe I draw a line here such that this particular pattern is classified, and then I draw a line here and then this particular pattern is classified, and then I can solve the problem. That is also a way of solving the problem, but I am not doing that. For a change, I want to now classify the patterns from class 2. So as to just show you what would be the difference if at all you classify the patterns from class 1 or if at all you classify the patterns from class 2. So there is a slight change. That is the reason now the line which I will select in step 3 will be such that it will be classifying the patterns of class 2. It is not compulsory, but I am just showing you because for the other problems you may have no choice but to classify the patterns from class 2. So that is the reason, since this is the problem which I am solving, I want to show it to you all. So next I draw a line somewhere here such that what is getting classified here, these two patterns will get classified here. So the name of this equation line, I will name it as line O3. So with whatever I have shown here, these 2 points, this one and this one will be classified, and these ones are the unclassified points. So you have 5 points which are unclassified. So we write the equation of this O3. So equation of O3 will be nothing but x1 upon 0.5 plus x2 upon minus 0.5, considering that the intercept here is minus 0.5 and here it is 0.5. You can take 0.3, 0.2, 0.4, whatever, but we usually take 0.5. So that is equal to 1. So I can simplify the equation, and here you will get not plus but a minus sign. Minus 0.5 is equal to 0. Now again, is 0, 0 point lying in this region? No. So when you substitute here, 0, 0 answer is negative. So we don't have to bother much about it. This equation which we have got is the correct equation. Okay. So only when 0, 0 is lying, that time we have to take care. So now we move on to the next step, that is we have to find what is N3 plus and what is, but before that we find what is T3 plus and T3 minus. So T3 plus is nothing but same as T2 plus because nothing from class 1 has got classified. T3 minus, now this was our T2 minus, the same thing. Okay, but T0 minus, nothing was classified. Now what is happening here? These 2 points are getting classified. So minus 1, 0 and 0, 1. So these 2 points are getting classified. So my set gets reduced to 0, minus 1, 1, 0 and 0, 0. So these 3 points are yet to be classified from class 2. So what is N3 plus and what is N3 minus? N3 minus is 3 and N3 plus is same as N2 plus, that is 2. So altogether 5 points are remaining to be classified. So we move on to step 4. Next line I will draw for maybe class 1 patterns only. So I can draw this particular line here, and this line will be named as say O4. So this line is O4. So it classifies which point? It classifies this point which was unclassified here, and these are still not classified. So 4 points are yet to be classified. So what is the equation of this particular line? The equation of this particular line is quite simple. That is, it is x2 is equal to 0.5. So I can write it as x2 minus 0.5 is equal to 0. And again we see that 0, 0 point is not lying. So we can, when you substitute 0 here, answer is minus 0.5. So you can consider that way and say that the equation is correct. So I can write the equation as x2 minus 0.5 is equal to 0. Now, what is T4 plus and T4 minus? At this particular step, we have to calculate T4 plus. Now, which is a pattern which is classified? 1, 1 is classified. So minus 1 comma minus 1 is still remaining to be classified, and hence n4 plus is equal to 1, and T4 minus, nothing is classified from class 1, so it is same as T3 minus, and n4 minus will be same as n3 minus, that is 3. So now we have to, now I think it is very simple that in last step, you can just draw one line such that it will separate these particular points. Okay, if at all I draw this line, it gets separated. So now we shall classify the points from class 2. So this is the positive direction that we take, so that all these points will be classified, and this is not classified. So it is as good as there is only one point. So both the sides, we can say that the points are getting classified. So we move on to step 5. That is this name line which we have selected. We name it as O. So direction is this, what I have shown here. Now please note, I have forgotten, whenever I have shown you all drawn lines and shown the region, the direction is very important. So I will just mark the directions which I had written, but they are gone. So O1 is in this direction, then we did O2 which was in this direction, then we did O3 which was in this direction, O4 was in this direction, and O5 is in this. These directions are very important. Okay? If all these directions are not mentioned in your diagram, then your problem is wrong. So for O5, the equation can be written as x1 is equal to minus 0.5. So that means x1 plus 0.5 is equal to 0. Now in this 0, 0 is lying in this particular region. So when I substitute 0 here, answer is plus 0.5. So again, we do not have to bother about the equation sign. So this equation is correct. So now the last step is to find T5 plus. Now what is T5 plus? What is getting classified here is 0, 0, 1, 0, 0, minus 1. These points I think classified here. So T5 plus is still left with minus 1, 1, minus 1. And T5 minus is going to be a null set because everything is classified. So it is a null set or indicated as 5, and N5 plus is equal to 1, N5 minus is equal to 0. So we have to stop this particular problem. So the termination criteria for Marchand's algorithm is when you reach that any one of the sets should be a null set. So any one of the set becomes null set, that is when you stop. So because that particular, any one of the subsets which you have got, the plus set and the minus set, or the class 1 set and class 2 set, whenever any one of them becomes an empty set, that is when you have to stop and your problem is done. But now, this is a Marchand's algorithm, so the weights are remaining. So we have in this step 5, in 5 steps what we have done is that we have found out the equations for O1, O2, O3, O4, O5. So how many nodes are there in the neural network? There will be 5 nodes in the neural network. So at step 1, what we have done is we have introduced the first node. Step 2, we have introduced the second node. Step 2, the third node, fourth node, and the fifth node. Now, how this particular network will be drawn is that in step 1, what we are doing, we are introducing node 1. And what is this node? So, in this particular network, there will be input layer, there will be hidden layer, and then will be the output layer. So, what we are doing is that inputs are fixed x1, x2, and 1. So, in the first step, what we are doing is that we are adding one node, that is the first hidden node we are adding. And what are the weights? Depending upon this equation which we have got, minus 1, x2 is equal to plus 1, and this is nothing but minus 1.5. So this is the network which we get in the first step. Now, this is step 1 network. Now in step 2, what happens is that this network, another hidden layer gets added to it. So another hidden layer gets added to it, and that is named as O2. And what I do is that I connect x1, x2 and the bias depending upon these weights 1, -1 and -1.5. Okay. Similarly, what happens in step 3 is that another node is added, which is O3. And again, I will give the weights, say whatever is there, -1, +1 and -0.5. And similarly, we have to do for step 4 and step 5. And then the main part is that how are these particular nodes connected to the output layer. So while connecting to the output layer, all these nodes, what shall be the weights? What shall be the weights here? So that is what is the question. So now we will be finding the weights for each node in the hidden layer, meaning from the hidden layer to the output layer, what weights have to be connected. From the input layer, the hidden layer, the weights have to be connected from these equations that you already know. But from the hidden layer to the output layer, what should be the weights that we shall see now. Now, when we consider this O1 classification, this classified the patterns from class 1, right? This again we took patterns from class 1. Here we classified the patterns from class 2. Here we again classified patterns from class 1. And here again we classified the patterns from class 2. Now the equation for the weights at any step k is nothing but 1 upon 2 raised to k if it classifies class 1 and it is minus 1 upon 2 raised to k if it classifies class 2. So the first case, first step, k is equal to 1. So what is the weight? W1, the weight of the first layer, first hidden node is nothing but 1 upon 2 raised to 1 because it classified the class 1. W2, here k is equal to 2, second node. So it will be 1 upon 2 raised to 2, again positive sign will be there because it again classifies class 1. Here it is class 2, for k is equal to 3, we are classifying class 2. The line O3 was classifying class 2 patterns. So W3 will be minus 1 upon 2 raised to 3. Here k is equal to 4, so W4 will be again plus, but 1 upon 2 raised to 4. And last case, k is equal to 5, we are classifying again class 2, so it will be minus 1 upon 2 raised to 5. Is that clear? So now what are these values? This weight is nothing but half, this weight is 1 by 4, this weight is minus 1 by 8, this weight is 1 by 16, and this weight is minus 1 by 32. So these are the weights which we get. Now we shall go to the next. So the first equation for O1 is minus x1 plus x2 minus 1.5. So I write minus x1 plus x2 minus 1.5. So the first node is connected. Second is plus x1 minus x2 minus 1.5. If you want a different color, I will take a different color. This is plus x1 minus x2 and this is minus 1.5. Third node is minus x1 plus x2 minus 0.5. So minus x1 plus x2 and minus 0.5. So this is what you get here. O4 is x2 minus 0.5. So x2 is 1 and this is minus 0.5. And what is O5 is x1 plus 0.5 x1 and this is plus 0.5. Now what are the weights here from the hidden layer to the output layer? That is already known. First weight is half. So this is half Second weight is 1 by 4. Third weight is minus 1 by 8 here, 1 by 16 and minus 1 by 32. Okay, so this is the multi-layer adaptive neural network which you have designed using the Marchand algorithm for corner isolation problem. Is that clear?